After years of talk and development, large-scale 3D printing technology is finally coming of age and starting to enter the construction industry. The technique is steadily evolving from novelty to practical application, and the prospect of seeing 3D printed houses in towns and cities around the world is now looking increasingly likely. 3D printing is the process of creating a three-dimensional object by laying down many layers of a material in succession. On an industrial scale, this has many advantages over traditional manufacturing techniques and has fast become a valuable tool for rapid prototyping in the manufacturing sector. If successfully scaled and applied in the construction and engineering industries, it could reduce on-site time and project costs. It also has advantages for sustainable construction, as very little material is ever wasted during the build process. Several organizations around the world are now racing to effectively scale 3D printing and to develop viable solutions for the building sector, with a particular focus on housing.
It's happening at a young startup called Relativity, a team of for-real rocket scientists pushing space technology by pushing 3D printing technology to its limits. Here they are printing rockets, nose cone to nozzle.
Rockets are the lightest weight, most expensive, largest, difficult to make thing that really 3D printing is the optimal solution for.
Relativity co-founders Tim Ellis and Jordan Noon both realized this while working at large established aerospace manufacturers, where 3D printing has been used for decades to make prototypes or a few parts here and there. They figure technology now makes it possible to think bigger. But to do this, they first had to build something bigger, the largest metal 3D printer in the world.
Made our own 3D printing head where we have aluminum wire fed in by this nozzle here, and then we're using an 11 kilowatt fiber laser to actually melt the aluminum. So as you feed in material on the right, then the laser melts it. So it's a very, very powerful laser. It can actually blind you from over 50 kilometers away.
Good thing they aren't evil geniuses. Their mega printer is called Stargate, a 3-armed, 15-foot-tall robot. It hasn't made a whole rocket yet, but it has printed out a fuel tank and an engine. Relativity's full-throttle thrust into 3D printing is just one milestone on the long road from prototypes and small parts to mass manufacturing.
What happens when you need a ton of things 3D printed in a short amount of time? You send them off to a 3D printing service. Today, we're going to go visit a 3D printing factory here in China.
SLA,
wow.
workshop.
Oh, wow.
We have 8 machines.
You guys have 8 machines here. That's pretty awesome.
Can we look? Oh, cool.
Oh, wow.
I've never seen that before in person. It's pretty awesome, isn't it? So are these all printing now?
Yes.
Some of them are finished.
You can see, this is printing.
Oh, just starting. Yeah.
Oh, I see. Yeah. Nice.
Is that resin?
Yes, resin, liquid, yes.
And so it adds more on top.
Yes.
Yeah, goes down.
Each step thickness is 0.1 millimeter.
That's how much?
0.1 millimeter.
0.1.
Yes.
Yeah.
We have 3 materials here. DSM.
Okay, yeah.
Made in Europe.
Yes. This is transparent part.
Are these machines made
in China, yes, but material in Europe. Also the laser part, made in
Germany, yes.
We might be printing this. We sent an order for 55 pieces of this yesterday.
How much does one of these machines cost?
Cost about $350,000.
It's like $50,000?
Yeah.
How many parts per day do you make here?
100 to 200 orders. This is 24 hours running.
Yeah.
Wow.
Yeah.
This is the temperature. Because of the laser system, the temperature we should control from the 20 degree to 30 degree. Humidity we have to less than the 40%. If the over 40%, the material will get a problem. We cannot use the white light in this room. Yes.
But why?
Because of the materials. Because this material is liquid material. When you see the white light, get a problem.
So if you use normal lights,
yes,
it will cure your material. Your material will get hard.
Yes.
So you use these like orange-yellow lights,
yes,
so that you can look inside the machines and open the doors without ruining them.
Yes.
Yeah.
San Francisco-based startup Apiscore have been working for a solution to homelessness and a lack of affordable homes. And they appear to have come up with an answer. The team hit headlines recently as they achieved a world first by creating an entire house using a 3D printer. Living up to their simple slogan, "We print buildings." More impressively still, the 400-foot square home was completed in just 24 hours. And of course, even the smallest detail had to be considered. The walls are made of a specific surface that allows the paint to be laid on immediately, which significantly reduces costs. And since it was built in Russia during the winter, the house has a flat roof to withstand high snow loads. Using special filler material that didn't require fixtures allowed the space between the wall and the outer concrete structure to be filled in and ultimately avoid cold drafts from gaps. But what's it like inside?
On the inside, the printed house is no different from a regular concrete house. It is also comfortable and reliable. The house interior includes a hall, a bathroom, a living room, and a compact functional kitchen with the most modern appliances.
The whole project cost a little over $10,000, which is an estimated 70% saving on an average home, and took a fraction of the construction time. The success of this project certainly makes a robust case for the use of 3D printing in the buildings of the future.